This is problem number 2 on page 695. We've got this system of parametric equations here. X equals e to the 3t and y is equal to e to the minus t. And we want to graph this thing on this interval from 0 to the log of 2, which is about 0.7, and then find the area between this curve and the x-axis over that interval. So when I plot this function, you can see that at these endpoints, at 0, I'm up here, at 0, both at t is equal to 0, we've got that xy is equal to, well, x would be e to the 0, and y would be e to the 0, so I'd be at 1, 1. And then at t is equal to the log of 2, or 0.7, we would see that xy would be equal to, when I plug in the log of 2, I get e to the 3 log 2 and e to the minus log 2. But let's rewrite this as e to the log of 2 all cubed, and the other one e to the log of 2 all to the minus 1. And you can see that what's going to happen is, well, e to the log of 2 is 2, 2 to the third is 8. And then e to the log of 2 is 2, 2 to the minus 1/2 is, or minus 1 is 1/2. So I'm at the point 8, 1/2. So let's plot these 2 points. At 1, I'm going to be up at 1. Let's put it right there. And at 8, I'm about 1/2. And if I wanted to, this would be 8 right here. This would be 1. And I could plot some intermediate points, but let's say the curve looks like this. Now what we want to do is to find the area underneath this curve over that interval. And you can see that what we want to do is to take the integral from 1 to 8 of y dx. Now when I flesh this out in terms of t, several things change. The y is going to be e to the minus t, and note that dx is going to be equal to, well, the derivative of e to the 3t is 3 e to the 3t, and then dt. So and this dx becomes all of this stuff. So I'm going to write this as 3 e to the 3t dt. And now when I switch from x's over to t's, note that when x is equal to 1, and x is equal to 1, t is 0. So I'm going to go from, instead of from 1 to 8, I'm going to go from 1 to the log of 2. Now I can simplify this expression. That's going to be, I'll bring the 3 all the way out in front of that integral. I'll go from 0 to the log of 2. I can combine those exponentials. So that'll be e to the 2t. And the antiderivative of e to the 2t is e to the 2t over 2. So I'm going to get 3/2 e to the 2t. And I want to evaluate at those endpoints. So I'm going to get 3/2 times this thing at 0. And e to the 2 times log of 2 is e to the log of 2 all squared, or that'll be 2 squared, that'll be 4. And this thing at 0 is 1, so I get 3. So I'm going to get 9/2 is our answer. 4 1/2.